Hello, my name's Thanom and I'm from UNSW. Today I'm working through some of the Math 1011 calculus questions from the section on integration and areas. So in question 8, we're asked to calculate this definite integral from -2 to 2 of x cubed dx. Now, just by knowing x cubed is an odd function and that we're going from -2 to 2, we might already suspect the answer. But let's just evaluate it using the fundamental theorem of calculus and confirm what we think. So, using the fundamental theorem of calculus, if I wanted to calculate this definite integral, I would need an antiderivative of x cubed. So an antiderivative of x cubed is x to the 4 divided by 4. And then I would substitute in these limits and subtract. So substituting in 2, we would get 2 to the 4 divided by 4, and then we would subtract minus 2 to the 4 divided by 4. Now 2 to the 4 on 4, that is 16 on 4, and we're subtracting 16 on 4, so we do get 0. So the reason we might have suspected that we would get 0 because x cubed is an odd function is because this is calculating the signed area from -2 to 2 underneath this graph y equals x cubed. So we're calculating the signed area, so the area to the x-axis, but because it's a signed area, areas above the axis will be positive and areas below the axis will be negative. And so if we're going from -2 to 2 of an odd function, which has some rotational symmetry, those areas are actually exactly the same. So this signed area is the negative of this area here, and so we know that they will add to 0. So the fundamental theorem of calculus, finding the antiderivative and subtracting, does indeed get us 0 there. Now, if the question actually would like us to find the actual area of the region bounded by this graph and the x-axis between -2 to 2, we can't just find the definite integral from -2 to 2. We have to realize that this area from -2 to 0 is below the axis, but this area from 0 to 2 is above the axis. Now, because there's some symmetry here and we know those areas are the same, we can just find the area from 0 to 2 and we can double that to get the total area. If it didn't have symmetry, or say we wanted from -3 to 2, we would have to separately calculate this signed area here and absolute value it so that we had a positive number and then add it to this section here. Okay, so the area, I might just write that the area is the absolute value of the integral from -2 to 0 of x cubed, right? So we know this is going to come out negative because it's underneath, so I would absolute value that, plus the area from 0 to 2 of x cubed dx, right? However, since it's an odd function and there's symmetry, we know that we can actually just take the integral from 0 to 2, which gives us this area, and double it here, right? So let's just say by symmetry, since x cubed is odd. Okay, so that's a nice fact. So let's just calculate this, which we've almost done anyway. We know an antiderivative is x to the 4 on 4. And we're going to substitute in these limits. So we have 2 to the 4 divided by 4 minus 0 to the 4 divided by 4 there. So here we have 2 times 16 divided by 4. So 2 times 4, which is 8. So we know that there are 8 square units of area. So these are actually 4 each. And that's the area of the region bounded by that graph between -2 and 2 there. Okay, so just remember the difference between calculating a definite integral, which is going to give us a total signed area, and a question that specifically asks for the area in which we would have to calculate areas underneath the x-axis as positive, right? And so we just have to have a picture of what the graph looks like in that case.